All right, let's talk about the 10 most popular problems that I believe every high school graduate should absolutely know. I know a lot of times when we're going through high school, we just go through the motions and then we look back and sometimes wonder, what did I really know, or what should I actually make sure I take with me? So I designed 10 problems that I feel every student should know how to do. And this should help them in college or if they go directly into the real life. I understand not every student is going to take calculus or upper level math classes, but that's okay. These are mostly going to focus on Algebra 1, geometry, and a little bit of Algebra 2. But these are the basics. So if you are a current high school student, make sure you kind of give yourself a little checklist. Do I know exactly how to do this? Or if you've already passed graduation, maybe just go and take a look back. Did I really get from high school what I was supposed to get? All right, so the first problem is a linear equation that we need to go ahead and graph. And you can see this is going to be in the slope-intercept form. Now, remember, when we are graphing linear equations, we need to make sure we understand what exactly is the y-intercept. That is where the graph is going to cross the y-axis. So we have the x-axis here, and we have the y-axis there. So in this case, you can see b represents a -3. So I'm simply going to go on my y-axis down 3 units. Now, I'm going to make a little point because that is going to be where my graph is going to cross. Now, m, remember, represents the slope. That is going to be the rise over the run, or the change in the y-coordinates over the change in the x-coordinates between any 2 points. So again, that's going to be consistent for all the points on the line. So all we simply need to do to graph a line is create 2 points and then connect them. So in this case, m is equal to 1/2. So again, the change in the y is going to be a +1. So I can go from this point, I can go up 1 unit. The change in the x-coordinates is going to be +2. So that's going to be shifting it over 2 units to the right. Now, that's going to create what we call a slope triangle. You can simply just follow this slope to find your next point. It also is nice to remember that, again, when you have a negative slope, or you can also take a positive slope and do the exact opposite. You can go down 1 and then to the left 2. And again, you're still going to have a point that's going to be on the line. The next problem is probably your favorite. Not really. We all know that nobody likes factoring. I don't care if we're dealing with freshmen or even dealing with seniors. Students always get tripped up sometimes with factoring. And it really just comes into practice, practice, practice. So throughout your time, how much practice have you done with factoring? Because I'll tell you, the more practice you do, the easier this problem is. And yes, by the time you're done with high school, we should expect that you can be able to factor some basic trinomials. So let's kind of go through a quick review. We know for factoring quadratic trinomials, we can break that up into a product of 2 binomials. The first 2 terms are going to multiply to give me x squared. So we know that's going to be an x and an x. To find the next 2 terms, what we need to do is understand that these 2 terms are going to multiply to give us -10. So what we need to do is understand, well, what are the numbers that multiply to give us a -10, but then are going to add to go ahead and give us a -3. So we think about this and we say, all right, well, -10, that means one has to be positive and one has to be negative. So we can look at this as a -10, +1, +10, -1. We could do a -5, +2, and we can look at this as a +5 times a -2. Those are all going to be the factors for a -10. Now, whenever you're looking at the last term is going to be negative, what you're looking for, I said like they're going to add to give you -3, but in reality, another way I like to look at this is like, what is the difference of the factors to give you a -3? So whenever your last term is negative, you know one factor is positive, one factor is going to be negative. So we want to look at the difference between the 2 factors. That's going to be a 3. So again, I like to look at it as 5 and 2, 10 and 1. Which of these have a difference of 3? Well, hopefully you recognize that's the 5 and the 3. However, we need to get this difference to be a -3. So what do you want, a -5 and +2, or +5 and -2? Hopefully you recognize that this is going to give us a -3. That would give us a +3. So now these are going to be the values of my factored form. And now I have factored successfully. One time when I was on a train, when I was still a teacher, I was on a train actually in Chicago. And I remember some people were doing like a little quiz between each other. And they were like older, you know, had already passed college. And they were just kind of going through like trying to remember some things from high school. And one of them like meant out was like, do you remember the, Pythagorean theorem? And they couldn't remember it. I was like amazed. But I think definitely the Pythagorean theorem, ladies and gentlemen, is one of those important formulas that you should remember from your high school days. Now, obviously, I was sitting there as a high school teacher, and, in high school is definitely very, very important. But I think there's a lot of real-world applications that you can use with the Pythagorean theorem, and I think it's just always important to recognize when you have a right triangle, you can always apply the Pythagorean theorem to find your missing side. The important thing is that we need to understand is when we are looking at this from our Pythagorean theorem is understanding what are going to be our legs and what is going to be our hypotenuse. So when we have a right triangle, we're going to have a right angle. Directly across is going to be our hypotenuse, and then the other two sides are going to be our legs. Now remember, the legs are always going to be shorter than the hypotenuse. So this is leg squared plus leg squared equals hypotenuse squared. So if I just go ahead and give this a variable, which is going to be my missing side, I can now say a squared plus 3 squared is going to equal 5 squared. Now, another thing that particularly you could go ahead and go for about this, but I actually forgot. I did this problem on purpose because also in geometry class, as well as in other math classes, you should recognize this is actually going to be what we call a Pythagorean triple. So if you recognize this relationship, the 5, 3, you should already know that this answer is going to be 4. That's a really, 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 really important relationship to go ahead and remember. And this is not all the Pythagorean triples, or this is not the only Pythagorean triple. There's many, many more. So I'd highly recommend just go ahead and refreshing your memory on those. But let's go and do the quadratic, or finish up the Pythagorean theorem, just in case you don't know what I'm talking about on Pythagorean triples. So in this case, we're going to square the 3, which is going to be a 9. And that's going to be a 25. I don't know why I put an extra equation sign. Now let's go ahead and subtract the 9, and I get an a squared equals 16. Take the square root of both sides. Now again, we're only dealing with positive sides of our triangle, and therefore you can see that a is equal to 4. Now, on that exact same train, they did the Pythagorean theorem, and then what do you think was the next formula they said? The quadratic formula. And do you think they could remember it? Well, no. If they couldn't remember the Pythagorean theorem, they were way off on the quadratic formula. So let's go back and do that, because if you are taking further mathematics courses, the quadratic formula is one of those foundational formulas that is expected for you to remember. Okay, now the quadratic formula is going to give you the solutions to your quadratic when it is set equal to 0. But it's important, not all quadratic equations are the same. We can only take this quadratic formula when we have a quadratic in standard form set equal to 0. Okay, so you can see here that is going to be our standard form where a and b represent coefficients and c represents a constant. We look up here and we say, it's already in standard form, it's equal to 0. Let's go ahead and identify our a, b, and c. Okay, so just remember when there's not a number present, we know that x squared is the same thing as 1 times x squared. So you can go ahead and insert those little ones there. They're not changing anything on the problem. They're just actually showing us, oh yeah, that can represent our coefficients. So now, since we have our a, b, and c, simply plug them into the quadratic formula, and then we can go ahead and simplify. Okay, so just remember it's opposite of b, right? So if that's a -1, that's why I wrote a positive. And notice I use parentheses. Remember, that's just going to keep everything preserved and nice and neat. So what I have here is 1 plus or minus. -1 squared is going to be a positive 1. -4 times -3 times 1 is a positive 12. 1 plus 12 is going to be a 13. That's going to be divided by 2. That's pretty good, but just remember you can also divide the 2 into both of those terms. And remember, you could think of a 1 as the coefficient of that square root. So x equals a 1/2 plus or minus a 1/2 square root of 13. Now you might be wondering on this one, like you're talking about high school, why are we dealing with fractions? I was amazed just as you were. I remember giving this problem to my pre-calculus students, and sometimes even to my calculus students, and would be kind of amazed on how quickly they forgot how to add and subtract fractions. It kind of scared me a little bit. And I understand that, we deal with fraction operations before high school, but students still struggle with them. I remember telling my mom when I first started struggling with math, I didn't like fractions. They confuse me. And a lot of us don't like them because they add extra steps when we're trying to solve a math problem. But I don't want you to be afraid of fractions, especially after you leave high school. And this is just a very basic problem just to remind you of what we can do. What are the operations of dealing with fractions? So when we want to add fractions, we need to make sure that we have a common denominator. In this case, you can see that I have different denominators of 2 and 3. So to find a common denominator, we need to find a common multiple of our denominators. A lot of times, a quick, easy way to do that would be to simply just multiply them, but that's not always going to be the case. In this case, though, that is exactly correct, because if I list the multiples of 2 as well as 3, you can see that the least common multiple is 6, which indeed is going to be their product. So what I need to do is create this least common multiple by creating equivalent fractions. So what I'm going to do is to get to 2, to get to 6, I need to multiply by a 3. But whatever you do in the denominator, you have to do in the numerator. That's going to be what we call creating equivalent fractions. That's going to now be a 3 over 6. And then for 3, to get to 6, I need to multiply that by 2. So I'm going to multiply 2 on the top and the bottom. And now I'm going to have a 2 over a 6. Now again, some of you might be able to do this in your head, and some of you might have completely forgot what to do here. I want to make sure we all know how to deal with some fraction operations. Now I have 3 plus 2 is going to be a 5, and you always keep the denominator, that is your common denominator, preserved. All right, so now we get to something that is not directly related to a Algebra 1 or geometry problem. We're kind of picking it up a little bit. Well, this one actually is in geometry, but also it's a fairly basic ones, even past geometry in like pre-calculus, that we want to make sure students would have a good foundation of knowledge knowing. Because when I tell my students when they see a right triangle, immediately the first 2 things I tell them to do is remember that, okay, we could apply our Pythagorean theorem as well as our trigonometric functions. So we have the sine of theta, we have the cosine of theta, and we have the tangent of theta. Now again, we need to remember what's the difference here. The Pythagorean theorem is telling us the relationships of the sides. Our trigonometric function is also giving us a relationships of the sides with respect to an angle. So when I say the sine of theta, which is going to represent an angle of this triangle, that is going to tell us about the comparison of how big is the opposite side over the hypotenuse. The cosine of your angle theta is going to represent the relationship between how big is the adjacent side over the hypotenuse, and tangent of your angle is going to represent that relationship of how big is the opposite side over the adjacent. Okay, so those are your trigonometric functions, and again, they can only be applied when we're dealing with a right triangle. So in this case, we need to find our missing side. And actually, I forgot to lay that in there. Let's go ahead and use x right here. So I have an angle, 30 degrees. That is going to be our angle with respect to that we're going to use our trigonometric functions. Now we need to understand, well, what are the opposite, hypotenuse, and adjacent sides? Remember from the Pythagorean theorem, we know the opposite side is going to be directly across from your 90-degree angle. That's going to be 5. The angle, or the side length, that is between your angle that you're referring to and your 90-degree angle is called your adjacent side. And the side length that is directly across from your angle is what we call our opposite side. So we need to go ahead and solve for x. Now let's go and take a look at what relationship do we have. We have the opposite side as well as the hypotenuse. So now I just need to go to my trigonometric functions and say, well, which one's that? Well, that's going to be the sine. So I'll write the sine with respect to my angle, 30 degrees, is going to equal my opposite side over my hypotenuse. Now, for those of you that have taken some trig in Algebra 2 and as well as pre-calculus, you might actually know what the sine of 30 degrees is. I don't have a calculator and I'm not going to use one. So if we understand what the sine of 30 degrees is, you could think about this from special right triangles as well as from the unit circle. But I realize not every student has taken those courses, so if you need to use a calculator, you could do that as well. But the sine of 30 degrees is going to equal sine of 30 degrees. That's going to equal, let's write it out. So sine of 30 degrees is actually equal to a 1/2. So therefore, I have 1/2 is equal to x over 5. Now, to solve for x, I just multiply by 5 on both sides, and I get 5/2 is equal to x. All right, so on this problem, I really think that as students are going through high school, it's just a good understanding to understand the idea of functions. And I'd probably say one of the most important things about understanding functions is going to be the domain and range. I also really like the understanding of transformations and students understanding how to take a function, apply transformations to get a different function. That's some really, really important stuff to be able to take away. You might not be using it directly in your real life or in the next course, but I think having a general understanding of how we can apply operations to a function and transform it is pretty important stuff. So I'm going to kind of work through this like it's an Algebra 2 type problem. And what I want to do is go ahead and use transformations to transform our parent graph. And then we'll go through the our understanding again for domain and range. So the parent graph, let's just call that let's call that p of x of the square root function, looks something like this. Now we need to remember our transformations. What is happening when we apply a subtract 2 inside of the function? That's going to be inside of the root, and a plus 1 outside of the function. So any operation outside the function is going to be what we call a vertical transformation. When we're adding 1, that's going to shift the graph up 1 unit. When I am subtracting 2 inside the function, that's actually going to be shifting the graph 2 units to the right. So it's important. Transformation or operations inside the function is a transformation left or right or horizontal. So if I want to be able to sketch what this graph is going to look like, I'm going to take my 1 point, which I know is going to be my intercept here at 0, 0. I'm going to shift it up 1, and then I'm going to shift it 2 units to the right. Now, the graph is going to look something like this, but let's understand what is representing the domain and the range. Remember, the domain is a set of all x values, all the values that you can plug into the function and get one single output from. So what that's going to represent is all the x values that are defined for this function. And you can see the x values are defined from 2 all the way over to infinity, because this graph is going to continue going to the right. Nothing over here is defined for this function. So we can see that the domain is going to be from 2 all the way to infinity. Any number that is 2 or larger, I can plug into this function and I'm going to get a value out from. And think about it, I can't plug in 0 because 0 minus 2 is -2. You can't take the square root of -2 in the real number system. The range is the set of all outputs, or the set of all y values that make up your graph. If you look at this graph, you can basically say, well, what are all the y values? Well, the lowest y value that we have is at 1. And then the graph continues going up and up. I know it's going up and up very, very slowly, but it's going to keep on going up to infinity. So the range in this case is the set of all y values that make up your function. Therefore, in this case, it's going to be 1 to infinity. All right, now on for number 8 is going to be solving a system of equations. In this case, you can see we have y equals a 3x minus 1, as well as a y equals -x plus 3. Now, you can solve a system of equations by, remember, graphing, elimination, as well as substitution. But whatever I tell my students is whenever you have a variable that's already isolated, substitution is going to be the easiest process. So let's go through it that way. I have y equals to a 3x minus 1, right? So what that means is I can replace this y with a 3x minus 1 and then go ahead and solve for x. Now, recognize that I have an x on both sides here. So what I need to do to solve for x is I need to get x over to the same side. So I'm going to add an x here on both sides. That'll give me a 4x minus 1 is equal to 3. Now I can just use my inverse operations to go ahead and solve. Now again, that is going to be the value of x that satisfies both these equations. But when we're solving a system of equations, we're looking for the intersection point, which is going to be a x as well as a y value. So to find the y value, I'm going to take my value of x and plug it into one of my 2 equations. It doesn't matter which one you'd use. I'm going to avoid a negative, so I'll plug it into the top. And there you go, ladies and gentlemen. We now have our value for x and y that satisfies the system. On to number 9, which is going to be finding the inverse. I think when we're understanding functions, if we're leaving high school with an understanding of functions, I think it's important to understand the domain, the range, how to do applied transformations, as well as find the inverse. Because remember, a function is a rule. And what's nice about the inverse is going to undo that rule. So remember, the notation for the inverse is going to be f inverse, or raise that little -1, is going to equal. So to find the inverse, there's a little bit of a step-by-step process. And I think it's important, just like the quadratic formula and just like Pythagorean theorem, it's important to remember. So whenever we're dealing with something in function notation, we're going to want to rewrite it as a linear equation with x's and y's. Now, what we're going to do to find the inverse is swap the x and the y variable, and then go ahead and solve for y. To solve for y, all I simply need to do is apply my inverse operations, subtract a 1 on both sides, so that's an x minus 1 is equal to a 3y, and then divide by 3 on both sides. So now I have y equals a x minus 1 divided by 3, but that is going to be my equation of my inverse. If I'm going to represent this correctly, since I was dealing with a function, I will write it in inverse notation. So f inverse of x is equal to a x minus 1 over 3. Now the last equation I actually went back and forth with. At first I included it, but then I'm like, who really cares if anybody remembers the rules of exponents? Like, let's take it away. And then I was looking at some other problems and I was like, you know what? I actually like the rules of exponents or I like a problem like this because it just reminds us of being able to follow some rules. And then also being able to follow a idea of being able to simplify an expression. But if you think I'm wrong on this, let me know in the comments down below what problems that I did not include in this video that I should include. And if I get enough of them, I think I might just have to make another video. But anyways, guys, this is number 10. Like it or not, this is the one that we have. So I have a rational expression with some variables and some numbers, and we need to go ahead and simplify. So the first thing I'm going to do is I'm going to get rid of these parentheses by using the product rule. Remember, the product rule basically states if I have a product, or it could be a quotient as a quotient rule, but if I have a product raised to n, then I can distribute that n, or that power, to both of my terms. So in this case, I'm going to have a 4a squared squared b squared times b to the negative third all over a to the negative third and b. Now remember, the product rule basically says, this is the power to product rule. Now the power rule basically states if I have a variable or anything raised to a power, and that's also raised to another power, then I'm simply, to be able to find that value, I'm going to multiply those two values. So therefore, this would be an n times a m. So 2 times 2 is going to be a 4. But there's one more thing I want to do before we get to that. The last one is going to be our negative exponents. If I have x raised to the negative n, that is the same thing as x raised to the positive n when it's in the numerator, or what we call the reciprocal. If I have x raised to the negative n, if I want to make that positive, I can just go ahead and reciprocate that and then use the positive power. So the reason why I'm bringing that up is because once I go ahead and simplify this to a to the fourth, so 4 a to the fourth, and then I have a b squared. If I want to rewrite this as something positive, then I'm going to put it in the denominator. So I'll have a b cubed here, and then this a to the negative third, if I want to rewrite that positive, I'll go ahead and put that in the numerator. So therefore, that's an a to the positive 3. Now the next rules of exponents we need to remember, if I have x to the n times x to the m, the power rule, we multiply them. But for the product rule, what we're simply going to do is add our powers. So in this case, you can see I have a to the fourth, and since these are all multiplied here, I can rearrange this to a to the fourth times a cubed. But either way, I'm going to go ahead and add the powers, which is simply going to be, let's go ahead and redo this over here, 4a to the seventh b squared over b cubed. Now, last but not least is going to be the quotient rule. Remember, if I have an exponent that's raised to the m over x to the n, well, if I'm multiplying I added, for division, I'm going to subtract. That's going to be an m minus an n. So in this case, I have a b to the 2 minus 3 is equal b to the negative first power. But if we want to rewrite that positive, we're going to leave it in the denominator. So my final answer of this problem, those are basically going to leave me out with 1b. My final answer would be 4 a to the seventh over a b. And ladies and gentlemen, I know this was not a perfect video with all the examples, but if you feel pretty confident on what I just solved, I think you did all right in your high school years. Cheers.